We're done. Ready? This is for quadratic factors only. Quadratics. Okay? This doesn't work for cubics or quartics. It's a formula. To be honest, I don't particularly like this formula. But eventually, I'm going to give you roots or zeros and ask you to write the polynomial equation or function. So before we gave you equations or functions, and you had to find all the roots or zeros, we're now going to give you roots or zeros and have you work backwards to the polynomial. This is kind of an intro to that if you have the roots or zeros, right? So if you have the roots or zeros of a quadratic, and you know the sum of those roots and the product of those roots, and you could find that just by adding them and multiplying them, you can write the equation of a quadratic factor pretty quickly. I don't particularly like it because the amount of work involved in this, I think it can be done in a more of like an analytical process than a formula, right? Where eventually this will break apart and you'll forget it, or you'll get things confused, right? So the formula is, if you have roots of a quadratic, then you can write the equation of that quadratic by taking x squared minus the sum of the roots, right? So whatever the sum is, times x plus the product of the roots equals 0 or equals f of x, right? I don't particularly like it because it is a shortcut in a sense. It works, but it's just like I think there's other ways that are better to address this. Anyway, you'll have to deal with it. It's part of the curriculum. So be careful. It's sum in the middle, product at the end. Think about when you're factoring, right? When you're factoring a polynomial or trinomial, and you want to check, does it factor x squared minus x plus 6, right? You're looking for two numbers that multiply, product of 6 that add to this number, sum, right? So if you can remember that, you should be able to remember this formula, but you got to pay attention because it's a subtraction in the little, if you want to call it a formula, right? There's a subtraction there. So just be careful. So I have two roots, 2 plus I, 2 minus I. So first of all, the sum of these roots is pretty easy. You just add them together, right? 2 plus I plus 2 minus I. Combine like terms. 2 plus 2 is 4. I minus I is 0. So the sum is 4. The product, on the other hand, is a little different. What color do I want to use? All right, so product, you're multiplying. So it's 2 plus I times 2 minus I. FOIL, distribute, whatever you want to call it. You're going to multiply everything in the first binomial to everything in the second, so that's going to be 4. Your outer product is going to be negative 2i. Your inner product is positive 2i. And your last product is a negative I squared. You should be comfortable with this because you've been multiplying conjugates together for some time now. The outer and inner will they'll always produce a 0 there when you add them together. That's how conjugates work. What does I squared equal?
Negative 1.
Okay, so it's minus I squared, so that's going to become a positive 1, right?
Yes.
Plus 4, 5, right? So my sum is 4, my product is 5. I can write this polynomial quadratic, right? So it's going to be x squared minus the sum, which is 4x, plus the product, which is 5. Pretty basic, but that's really where it's going. Okay? I personally don't like this process. You also learned a process like this last year where do you remember taking roots last year and writing the polynomials, working backwards? Please tell me you remember a little bit. My last period definitely remembered. Okay, so last year when you did it, you created a trinomial, 3 terms, and another trinomial, and then you multiplied the 2 trinomials together. That's 9 multiplications and a lot of combining of terms. I'm going to show you tomorrow a process. It's not a shortcut, it's just a different method that I think is the best way to deal with this in general. Anyway, your assignment today is, no, that's what I'm showing you tomorrow. So it's 1 to 3 on CE, 13, 14 on WE, right? Not a lot. The CE questions are conceptual questions. A diagram might justify your answer and whatnot, but anyway, that's where we're going. And that's all I have for today.